Today, we will be looking at solving a system of equations using elimination. The goal when using elimination is to try to get the coefficients of either the x variable or the y variable the same number but opposite signs. In this example, we have 6 and then we have negative x or negative 1x. If we were to multiply the top equation all by 6, so if we took and multiplied everything on that top equation by 6, then we would have, let's see, 6 times negative 1 is negative 6x. 6 times negative 3y is negative 18y. And 6 times 27. 6 times 27 is 162. Now, notice that I encapsulated all of the equation. Both sides of it multiplied everything by 6. Both sides of the equation. That is legal. What you do to one side, you can do to the other. As long as you do that, you're not actually changing the value of the equation. You are changing the way it looks. You're basically scaling it up by a factor of 6. Now, what that allowed us to do is, let me bring this over, the bottom equation. Now we're going to add. I normally teach elimination by addition. And in doing that, you're wanting to get the coefficients to be the same number but opposite signs. Now, negative 6x and positive 6x is 0. Negative 18 plus negative 7 is negative 25y equals 175. We'll divide both sides by negative 25. So y will be 175 divided by 25 is 7. And it's going to be actually negative 7. Now that we know what y is, we can turn around and substitute it either into the bottom equation here or the top equation. So let's go ahead and do it in the bottom one. So we got 6x minus 7 times negative 7 equals 13. So 6x, a negative makes a positive. And I'm going to subtract 49 from both sides. In doing so, that is going to leave us with 6x equals 13 plus negative 49. That'll give us negative 36. Now that we've got our variables on one side, numbers on the other, we can divide both sides by 6. And we find out that x is negative 6. So our answer is negative 6, negative 7. We know that because we solved for a y, that we must have an x, because these two lines are going to intersect. And the intersection is this ordered pair, negative 6, negative 7. Now let's look at another example. Sometimes it's better to multiply to get the y's the same but opposite signs. So you need to look at all of the problem itself and make sure that, 4 and negative 7, well, I could multiply the top by 7 and multiply the bottom one by 4, but that's multiplying both of them. I can look at my y's and only have to multiply the top one by 2 to get my coefficients to be the same number but opposite sign. So it doesn't matter if you get the x variable's coefficients the same but opposite sign, or the y's variable the same coefficient but opposite signs. Either one will work, but you're trying to eliminate one of them. You're either trying to eliminate the x or you're trying to eliminate the y, but you must eliminate one. Now, Doing this will leave us 8x plus 16y equals negative 24. I'm going to bring this problem, the bottom equation over. We didn't do anything to it, didn't touch it. That's negative 7x, minus 16y equals 23. Now, we're adding. 8 plus negative 7 is just x. This drops to 0 because we wanted it to go away. Equals negative 24 equals 23. Negative 24 plus 23 is negative 1. Since the coefficient of x came out to be a 1, then we've already solved for x. Now all we need to do is either take that x and plug it into this bottom equation or the top one. So I'm going to use the top one. 4 times negative 1 plus 8y equals negative 12. In doing this, in substituting the x into the top equation, I am solving for the y. So I get negative 4 plus 8y equals negative 12. I'm going to add 4 to both sides. 8y equals negative 8. Y equals negative 1. So our answer is negative 1 comma negative 1. Now let's work another example. In this example, let's look at our coefficients. I have a 4 and a 6, and I have a negative 2 and a 9. Really don't want to mess with the y's here. It's easier if I've got to multiply both of them to do the x's. So I'm going to try to multiply the top one and the bottom one in order to get the coefficients to be the same. Well, 6 and 4. I can make them both 12. Pretty easy, but I need to make one positive and one negative. You choose. It could either be the top one. If I do that, I'd multiply everything by negative 3. And in which case, I would turn around and multiply the bottom one by 2. If I wanted to make the top one a positive one, then I'd need to make the 2 a negative. Okay? I want to make them the same coefficient but opposite signs. Now, negative 3 times 4x is negative 12x. Negative 3 times negative 2 is positive 6y. Negative 3 times 26, that's 78, and that'll be a positive 78. Okay, now we're going to do the bottom equation. Okay, 2 times 6 is 12. That's what we're wanting, right? 2 times 9y is 18y. 2 times negative 3 is negative 6. Our x's cancel. We're going to add them together. 6 and 18 gives me 24. And 78 plus negative 6 is 72. And I left my y out right there. 24y equals 72. 72 divided by 24. You use a calculator, it's fine. 24, divide both sides by 24. Y equals 3. Once I've figured out what y is, now all I have to do is substitute the 3 either into this equation for the y variable there or into this equation in place of y there. I'm going to put it in the top one. That's positive 3 equals negative 26. So 4x minus 6 equals negative 26. So I'm going to add 6 to both sides. 4x equals negative 20. Divide both sides by 4. X equals negative 5. So our answer is negative 5 comma 3. Anytime you solve for x and y, you must leave your final answer as an ordered pair. All right, let's do one more example of having to multiply both equations, and that should wrap up a review on solving systems by elimination. Do remember that if your variables drop, you have a potential of two possible answers. And what you're left with will be numbers. Either left side is equal to right side, which would be infinite amount of solution, which means it's the same lines. Each equation is the same line. Or the left side is not equal to the right side, which would give you an answer of no solution because those lines would be parallel.